Yo, good morning, good morning. So we're gonna continue with the migrating to Unity 6 today. Hopefully get rid of all these warnings. But we're gonna start where we left off yesterday. And as you can see, we now have a working outline render feature in Unity 6. Partly. And I say partly because our outline render feature has two outputs basically, or two exit points. One to the screen, which we have working here, and one is to a texture that we want to make global, so it's available in all shaders. The second part we think we have implemented. We haven't tested it just yet, and we're going to do that today. But before we test that one, we're going to convert a second render feature, which will be which pretty much just takes the scene color at a specific point and renders it to a render texture, which will also be available globally. So it's pretty much, we want to make a custom feature that gives us something like this opaque texture. And we want to do it ourselves because we want to have a little bit more control over it, MIPS and such. And the idea is that if we implement this render feature in the same way as we do the outline, and then we can test them both at the same time, pretty much. Dramo, hey, was the water in starting Zoom screen made by you? Yes, it was. Just before, or at the end of 2024, we started doing a water shader and everything that comes with it. And we're going to continue with that water shader. I just want to migrate this project to Unity 6 before we do. It looks so good. Thank you. Appreciate it. But we're going to make it look even better eventually. Okay, so let's take a look at create scene texture render feature. This is the one we're going to work with today, or initially today. We're pretty much going to implement it exactly like this. So I guess we could take this pass and copy it into the other render feature. But first, we're actually going to do this here. So the idea is, I'm not entirely sure just yet if this is the best way of doing things, or if it's even a workable way of doing things. But the idea is that the textures we want available all from every shader in the project, we instantiate them as a render texture in the renderer feature, and then we fill that render texture with information during one of these passes. I think it's a pretty good, I would be okay with things working like this. I'm just not sure if that's how they intended it to work. Yeah, what's up, Smack GDs? It goes pretty well right now. In the process of migrating the project to Unity 6, had some problems the first week. Since then, we have been smooth sailing pretty much. How about you? How are you doing these days? So what I'm getting at is, yeah, we have some to-do notes here. Is also the case for create scene texture. You can see here that I'm not 100% sure that this is how it's intended to be done. And that's why we have not one, not two, but three to-dos here related to this. But yeah, so let's do let's create a render texture here as well, which we call scene T. We pretty much want to instantiate exactly like we did with the previous render texture. We need to get the, oh, we don't want to do it here. Early morning. But let's do it here. And we need to get the camera as well. Graphics format. I wonder which of these we need. Rendering universal. This one we do need. Let's put this line here as well. Experimental rendering. Don't like the word experimental, but that's unfortunately where we have the graphics format, it seems. So actually these, I'm in refactoring limbo with my inventory stuff. The good kind of refactoring limbo or the bad, or actually the word limbo pretty much implies it's the bad kind, right? I do enjoy refactoring, but I do know the feeling of ending up in that limbo, and it sucks. Hope you find your way out soon. Yo, good morning, Derek. Okay, so we do the exact same approach here. We take the camera and create a render texture with the same pixel width and pixel height and so on and so on. We create the pass later on, which we call create scene texture pass, which is a pretty good name, so we're going to leave that. Don't think we need any settings. And then we enqueue the pass, and I think that's all we need to do. At this point, I'm wondering, outlines to texture pass. Yeah, we might want to have I'm a little bit. Yeah, one thing I'm wondering, yeah, we're gonna do set global texture here eventually. We don't instantiate the different pixels here, I don't think, which means that if we try to fetch this at right after this point, we might not be getting anything. So it's very important that everything that needs the outlines texture and the scene texture, that we try and use them after this. Otherwise we would be getting, I guess the first frame might be screwed up. But yeah. We have this one here. I think we're gonna move this one down to here. As much as it is, if it was code used only by me, I'd leave it at that, but for public consumption, it's just not good enough. Oh, I get that, I get that. I think I spent like the outlines feature, for instance, when I initially implemented it, it took a long time. And then before I released it for public consumption, it took way longer to get the code in a clean state before I released it. So I understand and I get it. Okay, all of this is quite different this time around, so I think we might even do this. And we might do this as well. We're going to start fully from scratch, but that's not entirely true because we're going to copy this as well. Outline render target handle. I'm also a little bit... I don't know about this one. I don't know if we need it. I wonder if this is enough. I guess we're going to have to find out. But we're going to take this one, put it here, record render graph. We have some errors. We're going to fix that. But I also want to take these two. Create scene texture pass name. Okay, we're actually only going to take this one and put it here. And we're going to call this scene RT handle. Then we do record render graph frame data. We get the resource data. We might, yeah, we need this one, but we don't need the outline data. Then we do texture handle, and we're going to call this scene texture handle. I'm just going through this instead of changing or fixing everything at once, like every outline data and whatnot. I'm going through this line by line because I want to make sure like I understand each and every step. Just refresh my memory, you know. And then we do render graph import texture. We do scene RT handle. Before we do this though, we're gonna have to create this one. So we're gonna add a setup method, which we're gonna call before we enqueue the pass. So create scene texture pass setup. In this case, yeah, we want to send in scene RT. And let's see here. If it's equal to null and RT, we release and then allocate a new one. I'm gonna call it scene RT. Actually, this one we want as scene. There we go. This one is supposed to be scene RT. We don't need to configure depth for this pass, so we're going to skip that one. And I'm going to remove this one for now. We're not utilizing it. So our setup here is just, if this one is null, or the render texture that is referenced in this one is not the same as the one we send in, we release the old one and allocate a new one, right? Yo, good morning, Geralt, good morning. So back to record render graph. We get resource data, we create a scene texture handle, and then we do render graph utils, this one we need. I thought, render utils, we need this one as well. So then we create a blit material parameters, and we call this one generate scene texture blit parameters. The good thing with this one is, here we're gonna take, we're gonna blit from, we can remove this one. We're gonna blit from whatever we have in active color texture right now. So what we have in the I don't want to say frame buffer, but what we have queued to be outputted to the screen, we're going to blit from that one to our scene texture handle, right? The thing with this one is that we're not actually going to use any material here. We're just going to take it and blit it into a texture. So I wonder if we can do this. Or can we do render graph, add blit pass, source destination, scale and offset, because we don't want to have custom material in this blit. So we might just do it like this actually. And what more did we need? Scale and offset, and we're just going to put the scale is going to be 1. We want 1 to 1, and the offset is going to be 0. So we don't need these actually. So this is a very simple, extremely simple renderer feature. We're going to add some additional stuff to this one and this one, because it's very important for us that when we generate this texture, that we generate it with a set of MIPs, like downscaled versions of the texture, because in our blur solutions, we utilize these MIPs to optimize it a lot. So instead of doing a blur with a, let's see here, 9x9 kernel, you can do it with a 1 downscale in MIPS and then a 3x3 kernel, pretty much. I don't know if they are 100% equal, but you get the idea. We get some kernel blurring for free, pretty much, or not for free. We're gonna do it here, but yeah. So I think that is about it. Before, I don't really know how. Okay, I have some idea of how we can test this, but before we can, we're gonna test it with transparent blur box shader. Transparent blur box shader uses a texture called outlines and scene texture. And those are the two textures we generate right now. We're not setting the global shader reference just yet. I want to do, let's take this sphere, and I guess we can put it here, and let's see if we have a misc. Do we have some blur material here? No. Prototype materials, transparent. Like, let's take this one. What do we have? Transparent blur box, beautiful. So we take this one, assign this one. Specular threshold. And let's do it like this. Right now we don't have, like, we should be seeing the character through this one, but we don't currently. I guess that's because, or I hope that's because, we never set these references in our render features. So if we do, so this is where we're going to test this solution if it works. So pretty much shader, set global texture. We probably want to do some static read-only strings here as well for these two. but we're gonna wait a second with that. And we just call this one outlines. Outlines. And then we do set global texture. This one is scene texture. Fuck, am I? No. This one is outlines, and we call this one outlines texture name. And then here we do outlines texture name. And we do outline RT. I'm a little bit worried about this. Instantiating a render texture here, then we fill it up during render passes, but it's always available in the shaders. Then we do create scene texture. We want to do the same thing here. We're going to do it here. So shader, set global texture, scene texture name, and scene RT. Which should hopefully make them available here. So we can utilize them here. Worst case scenario, we get a crash. Okay, we have outlines here. That's good. I actually think we have... We might actually have the background as well. Let's see. And then let's bring this one down. Okay, we don't have the scenes just yet, but we do have the outlines. Interesting. Very interesting. Looks pretty good. We can also see here that we get... Yeah, we have a fully gray texture. Okay, so our scene texture doesn't get sent in. I wonder if that is just a... that I named it the wrong way. So let's take a look. We call it scene texture here. I know why. We call it scene texture here as well. But the reason we don't get anything from it is because we haven't added it here. So let's add it, and we call it create scene texture. Let's bring it up. And I don't want to do it before rendering. I want to do it after rendering opaques. Or actually, do I want the skybox as well? I'm pretty sure we want the skybox as well. And I hope this is still correct. So we do this render feature first, and then this one, even though both are after rendering skybox. Let's try it this time around. Yes, that looks good. And if we do, yo, what's up, Calvino? If we now take this sphere and we add some blur to it, if we do kernel size 2, 3, 4, 5, 6, 7. If we do 7, we get... Jesus Christ. Do we actually get this performance with the kernel size of 7? What the fuck? Yeah, that's pretty good. Kernel size 9. Are you serious? What the fuck? 10, 10, and there we go. Yeah, it was pretty small, but this is still way better than I anticipated. A kernel size of 9 is extremely big. So like, we're rendering at 1440p right now, and for each pixel, we take... Let's take a look at this one. For each pixel, we take Jesus, we take a kernel of, what is it, 19 times 19. Am I seeing that correct? 19 times 19, and we blur it. This is extremely good performance. Given that fact. Huh. $361. Is that so? I'm have to double check my own code if that is really the case. Kernel size 9. So our kernel size is 9. So take a look at this. This is pretty insane. So we go from -9 to 9. Let's see here. Like, do we want to go from -9 to 9? That's 19 steps, right? And then we have, like Calvino said, so 19 times 19 is 361. This pretty much means that's, so like for each pixel in this 2K resolution, for each pixel, we do 361 times 2. We do 722 texture reads. Huh. Okay, I'm happy with that. That's extremely, if we do 3, this is a kernel of 7 times 7. Still pretty damn good. And this is without default blurring, which we're gonna try and see if we can fix now. Okay, I'm very happy with this result. Derek, that's insane. Yeah, I think so as well. An awesome work. I appreciate it. I think the new render graph system behind the scenes is doing a lot of heavy lifting here. I don't know if I'm gonna have to research this eventually. Let's see here. Questions I want answers to. Why is the blur so or the custom blur so performant in Unity 6? Okay, if I get to the bottom of that, we can probably use it for a lot of things. Calvino, sounds like Unity 6 has some performance improvements. It definitely does. Definitely does. Hope I'm not reading too much into this, but let's see. What we want to get working now is default blur level. So when we do blurring, or our implementation of blur, or the standard way of implementing blur, I guess, is we have a kernel size. So let's just draw this real quick to make it crystal clear. So when we have two different ways of blurring. We have by kernel, and when we have a kernel size of 1, we pretty much take, for the pixel we want to output a blurred value to, we take 1 step in the horizontal direction and 1 step in each vertical direction. So when we calculate the blur value for this pixel, we pretty much read all of these pixels and then we just mean the value. So we read all of these 9 pixels, add them all together, mean it, and output it. Eventually we're gonna do Gaussian blur because I think that looks way prettier as well. And that's just pretty much this, but we have different weights for this pixel. So right now we have a weight of 1 for each of them. So each pixel has the same, affects the output the same. But if we do Gaussian, I don't know the nicest Gaussian, but it might look something like 0.5, 1, 0.75, 0.5, and so on. So we just weight them different, add them together, and then mean it. But anyway, this is like the kernel way of doing blur, and this is, it's very costly, or at least it used to be. It's quite costly now as well, but way better. So we want to get some of this blur for free, and what we do, so we render the full screen to a texture, and then we want this one to generate MIPS. So that's pretty much just, we generate additional textures that are half the size of this one in every step. So if our initial texture is has a width of 2560, the MIP level 1 has a width of 1280, MIP 2 has a width of 640, and on it goes. So if am I getting this correct? I would like to get 2560 divided by 2 divided by 2. Thought we were getting the power of 2s here. I don't know, but that's pretty much the gist of it. So when we want to blur a big area, or we want to do a very big blur, instead of making this kernel bigger and bigger and bigger, which is very performance heavy, we just fetch one of these downsampled textures, which means that we get a lot of blur for free. Or we don't need to calculate it by kernel, at least. So then you could do, so maybe if you want a lot of blur, you can sample from this downsampled texture, and then you also add a kernel to it, but a small kernel, just to make it a little bit more, make it a little finer. And I don't know if we currently generate these MIPs, and that's what we're going to try. Right now, the only code we have that implies the generation of MIPs is, if we take the scene texture, for instance, is this parameter right here. So when we instantiate this render texture, we tell it that we want to generate all MIPs for this one. I have a little, I'm assuming right now that we just allocate memory to make this possible. We don't actually generate the MIPs, but I might be wrong. We're gonna take a look at that. In our previous implementation of this render feature, we had to, so when we do this blit pass, we also tell the command buffer that we want to generate MIPs after. I don't know if we can check this one here. Can we make this one bigger? So the previous solution, we had something like this here. We did a blit from camera color target to the texture handle. And then we had, if settings.mip count is not equal to 0, we do command buffer generate MIPs for this one. And I'm thinking that we need to do something similar here. I'm also thinking that when we create the render texture, we might want to set auto generate MIPs to false and stuff like that, because it's a question of how much control we want of this, when to generate them and such. I wonder if this one is true, that like Unity have some sort of flag that as soon as we change like 1 pixel of the render texture, the flag gets set, and if the flag is true, we regenerate the MIPs, but we'll see. We will see. Yeah, we can try this with this by changing this default blur level here. I'm gonna show what this one does. So We have kernel size, and then we have default blur level. And here we can see default blur level. It is sample texture, 2D LOD, scene texture, UV center, default blur level. And I can also see here that we don't do it for pixel outline data currently, which I find quite weird. But no, okay, I get it. We want pure data here because of depth, but later on down here, when we do the kernel values, here we can see sample texture, 2D LOD outline data, default blur level, and default blur level. And this last parameter here is the MIP level, right? So if we have a default blur level of 0, we get the first texture, so MIP level 0, which is just the default texture. But if we change this one to 1, we should be getting the downsample 1, and 2, and 3, and 4, and 5, and so on and so on. And we can see here that nothing changes. Good morning, Harukanan. Nothing changes, which tells me that we don't have any MIPs for this scene texture. So let's get to the bottom of why we don't. And I think we can do this in... I think we can do it here. Let's bring this one here, and we should be seeing, we go 3, 4, yes. Okay, so this one works here. 4. So let's take a look. Render texture, I wonder if we want to set some stuff here. In this constructor. Let's take a look at render texture documentation. Do I have it open? Probably not. API. Anti-aliasing, we probably want to, yeah. I'm gonna set anti-aliasing on this one. We can wait with that one. Auto-generate MIPs. Okay, so this is just MIP count. So I wonder, auto-generate MIPs. We can set this one to true. And try with that one. Bind texture. I don't think we need to set this one, since we passed this one into the constructor. But let's just be let's take the safe route. Okay, so now I think we have done every setup we need for the scene RT. I want to see if this works, and then I want to see if we can do, if this works, I want to do a solution where we generate the MIPs here. So we set this one to false, and then we manually generate the MIPs. I don't know which option is best. Or actually, if this works, we might just leave it like this. Maybe. I guess it's just a question of, so right now this texture, we only write to it once, and we do it in this blit pass. So if we just do this once, if it generates the MIPs after this, it's okay. What I would be afraid of is if we write to the texture, and then in the same frame a little bit later we write to the texture again, that means that we generate MIPs 2 times when 1 would be sufficient. I think if we take a look at the outlines as well, we only write to it once as well. Okay, but let's see what we get from this. And now we can see here that we actually get some default blur level. Unfortunately, we have outlines here screwing things up for us, but if we do 0, 1, 2, 3, 4, 5. So this seems to work. Rendering an unwanted nip, is that like a nip slip? In some in some ways, yes, I guess. But we're talking about, this might be hard to hear, but we're talking about MIPS with an M. So M, I really need to learn the phonetic alphabet, but M as in Mike. Yeah, there we go. So a MIP slip. Okay, so this seems to work, and I think we're just going to settle at this solution. This might be good enough. I would like to... Maybe we can... I don't know if we can take a look at the profiler and check if this happens more times than we want it to, the generation of the MIPS. I want to run this as well and see if it looks good in motion. So it's very important that we don't get, that we lag one frame behind. So what I'm talking about is we rendered the scene color, but the MIPS we generated are from the previous frame. We want to avoid that kind of stuff. But let's take this one, go to our outlines renderer feature and do the exact same instantiation here, which should mean that we get the outlines as well. I hope. Yeah, we do. So look at this. If we want this one to blur a lot, we can do default blur level 3. So we read from MIP level 3, and then we add a kernel size of 1, and we get a lot of blur. I know that I've gone through this previous as well, but I just think this is a very smart way of doing things. And like this blur, if we went only kernel, would probably be equal to, yeah, we're talking about 13 maybe. So that's 14, no, that's actually 27 times 27 kernel. But yeah, let's see if this works during runtime as well. So default blur level 3, yeah, it seems to work. And if we do it like this, you can see we have some, if we only rely on the downsampled versions, we have some sort of artifacts, but it can also look like frosted glass, you know, we get that for free. And that's why we can change this one to make it a little bit smaller. We can go 3, 3. Beautiful blur. And I also want to show, let's do 0, 0, and then we take this sphere and we make it extremely big again. And we bring it, where do we want to bring it? Here. Maybe. And then we check the performance again. So let's position this character. And let's do, so if we do a kernel size of 9 here, we get this much blur, but performance heavily affected. If we instead do MIP level 3, we get a lot of blur. Performance is pretty much unaffected. We get some drop there, I don't know why. And then we do 1. So we get as much blur with pretty much no performance loss, I would say. Maybe a tiny bit, but yeah. Very good. Okay, this actually went quite a bit smoother than I anticipated. 50 minutes. Okay, so this is very nice. This is very nice. Create scene texture. Pretty much done with this one. Although I am a little bit worried. I'm gonna add one task here so I don't forget. Research pros, cons by using auto generate MIPS equal to true instead of doing it manually. Like, in most cases, I do like to rely on like the first party, like Unity implementation of stuff. Because you get a lot of things for free. Like, it's one thing. We can take this one as an example. We could do the blit using the blitter.blit, but they really emphasized in the render graph thread that you should rely on this one because they are doing a lot of work behind the scenes on this one. So like if they optimize this, we get some optimization for free since we're using this one instead of, I think it was unsafe pass with blitter.blit or whatever it was called. Okay, good. I'm wondering if this one is actually fully done right now. I'm wondering if this one is fully done. And this one is probably also... I'm going to commit this. It's definitely in a acceptable state. And then we might look into this one. I have an issue here which I'm also very much interested in. Let's see, let's jump to that issue. Where do we have it? This one. Research the render texture resolve AA function call that happens every time some render texture is handled by a custom renderer feature. So this was the previous render pipeline system before render graph. And this one caused quite a lot of headache because Resolve AA, we got some anti-aliasing on textures where we didn't want anti-aliasing. Yeah, my description here is pretty good. This call seems to apply AA to an image before moving on in the pipeline, leading to textures consisting of pixel-perfect data, like the normals for outlines, being fucked up, okay. This call also seems to be very costly, so getting rid of it would be preferable. I don't know. I guess we can take a look at this. So our solution previously was to just disable MSAA, which, like, I feel like we want to have MSAA in this game on the higher graphical settings because it rules. But if it comes with the cost of screwing up our data behind the scenes and a lot of render texture resolve AA problems, then we don't want it. You also have this problem with, I don't know how it's with this new outline system we do. It has gone through a lot of changes since I made it public on GitHub. But the previous outline solution did not work with MSAA. So the fix was to use some other anti-aliasing algorithm on the camera. I think they are called like FSAA or something like that. I wonder if I have an issue concerning that as well. We can take a look, because we might be crossing off some issues here when we do this migration as well. We might be getting some things for free. Let's see here. I'm just thinking about what I want to do next here. I'm thinking, let's take a look at this one. Let's see what we have. Let's look in the, let's enable MSAA. Let's take a look in the frame debugger, see if we can find any render texture resolve AA. And just take a look at the state of this one. And yeah, depending on how that goes, we might do something related to this, or we might move on to these things. I'm also very interested in taking a closer look at this one, optimized render graph implementations. I want to see what kind of tips and tricks they have and see if we can apply it to our render features. But first of all, let's take a look at this one. So if we go to our pipeline assets, we have anti-aliasing MSAA here. It's disabled for all of these. I don't know if I have... Let's just try and enable it and see what happens. Let's go with 8x. Yeah, we get a lot more blur, and we also get thicker outlines. And I think we get thicker outlines because we do anti-aliasing on the... We can see here from the get-go that one sec. Do we not get any... maybe it's only on moving. But we can see here that we get thicker outlines instantly, and that I think that's because we do MSAA on our outline data. And that's something we don't want to do. We can also see here that we have some... My solution to not being able to rely on MSAA for our outlines was actually to implement anti-aliasing naturally in the outline shader. So you can see here that we get some lower alpha outlines here on the edges, and that's actually how the outline algorithm works. So we get some anti-aliasing for free. So the MSAA here is more for objects, for all other types of objects. So for everything excluding outlines. So we know that MSAA here does not work on the outlines, because we can see if we enable it here, we get thick outlines and they are not anti-aliased. And the reason we're getting thicker outlines is because I think our outline data gets anti-aliased. So let's take a look at the frame debugger here. What do we have? Do we have any resolve AA? I don't see any resolve AA. But if we take a look at this one and we disable this one, I want to take a look at it again. So this is disabled. We can see here that we have very pixelated edges. How did it look with MSAA? Very anti-aliased edges here. So we can see here that when doing MSAA, enabling it here, we do anti-aliasing on the data as well. So pixel perfect data, and we definitely don't want to do that. I don't know. We probably want to do it for the scene. Where do we have? We don't even have it here. I wonder if it's this one that takes the scene color. I think it is. Here we have Resolve AA. Is that the only one we have? Resolve AA. Okay, we get 3. Resolve AA on this one, Resolve AA on this one, and Resolve AA on this one. I want to find... We get one Resolve AA here. I think this is the scene color texture. And then we get one Resolve AA... Okay, let's do it like this. There we go. Where do we have our Resolve AAs? Render texture Resolve AA. Huh. But we can actually do it like this then. Resolve AA. Okay, so I think one of these is for the output to screen. We want Resolve AA there. Is this a performance hog, by the way? AA, yes, it is. Disabled. Actually, maybe not that much. But anyway, one of these are for the when we render the scene color to output. The second one is for this data, and the third one is for when we output it to the screen. So if we have MSAA in our project, we get 3 Resolve AAs. Best case scenario would probably be... I would love if we only got one Resolve AA and we had it at the end of the render pipeline. So right before we put it to the screen is when we do Resolve AA. So I'm hoping... fuck. Yeah, I don't know. We can test this though. So we have 3 Resolve AAs. For the outline data pass, makes me wonder. I wonder if our outline data also gets resolved. Let's take a look. I'm wondering if we can do... If we can... So when we instantiate outline RT here, not this one actually, but when we instantiate... Where do we have it? When we instantiate this destination here, create texture, outline, data, texture description. So this is the texture that handles the normals and segment data. We don't want to anti-alias this one. We want it to be pixel perfect because this is data. It's not something we want to display. So my question then is, if we do outline data texture description, do we have some anti-aliasing stuff here? Actually, we want to change a lot of things here. Auto generate MIP maps, false. Outline data texture description. Find texture MS. Let's go through these in texture desk. Okay. Fields. Aniso. I'm not entirely sure, but if I remember, I think this has to do with looking at the texture from a steep angle. I don't know. But okay, auto-generate MIPS. This one is pretty straightforward. Definitely want false there. Bind texture multi-sampled. Would love some more description. Let's take this one. Yes, okay, beautiful. If true and anti-aliasing is greater than 1, the render text will not be resolved by default. Use this if render text needs to be bound as a multi-sample texture in shader. We definitely want to multi-sample this. Multi-sampled. Are they referring to the general term multi-sampled, or are they referring to the term multi-sampled in reference to MS AA? Because I'm wondering if this is like there will be cases where we want to sample this texture multiple times in close succession and sample the neighbors of a pixel in it. But we don't want to do it for the purpose of AA, if you know what I mean. So I'm not so sure about this one just yet. Clear buffer, clear color. I think it's okay. I wonder if there's are any negative connotations from setting this one to true, just to make sure that we don't read from some memory we shouldn't read from. Fast memory, I have no idea. Filtering mode, we want to do point here. I don't know if that's the default, but filter mode point. Format, scale, height. This one should be false by default, I think. MIPMAP bias, MSA samples, number of MSAA samples. It's not very descriptive, this documentation. So I wonder if MSAA samples, do we have it here? No. Like, I wonder if we set 0 here, I don't know. Okay, that's descriptive enough for me. Name, scale, size mode. Use MIP maps, texture need MIP maps. Beer width, wrap mode. I think we want to do wrap mode lamp. Okay, the only flag I'm a little bit out of is bind texture MS. Actually, let's put these like this and filter mode point non-clamp. Bind texture MS, let's take a look at this one again. I'm gonna assume that this one is roughly the same as this one. If true and anti-aliasing is greater than 1. Anti-aliasing. Yeah, we don't have that one here. Yeah, I don't know. Texture disk bind texture MS. But if we do this setup, this one is probably the most important one. So my question now is, will we do resolve AA if we have MSAA samples as none for this one? That is my question. Let's restart it to make sure we have the latest changes. So which one of these screws it up? Let's do it like this. This one is the most important one, so I sure hope this isn't the one. Okay, exactly what we didn't want. So if we take a look at this one, it might be a... That one works. Works. That one works. And I don't see why this one wouldn't work. Okay, so if we disable MSAA and we bring this one back, the error we get is also very interesting. Okay, if we enable this one, let's disable it again. Mismatch in fragment dimensions. Out of these errors, this one is the one that makes the most sense. This one, I have no idea. Trying to use texture main light shadow map textures that was already released or not yet created. I wonder though, this error might just be like we get this exception and then more things starts to break. So I think we wanna focus on this one. And why would MSAA samples none cause a mismatch in fragment dimensions? Unity 6 render graph mismatch in fragment dimension. We get this exception and we get this one. Do we have any replies? No, we don't. But he replies himself, maybe. Do we have a reply here? No, we don't. Okay. Okay, here, let's see. So your original mismatch in fragment dimension problem is you mix MSAA and non-MSAA buffers for color. Okay, beautiful. That's exactly what we do. Which is not possible. Huh. Okay, so I guess when we create this one, this is not the issue itself. The issue comes later on when we do this one. Outline data, texture, outline texture handle. So I'm thinking, no, I think the problem comes when it probably comes here as well, since we have MSAA enabled on this one. But the biggest hurdle to pass is going to be this one, because this is where we split outlines onto active color texture. So what I'm trying to say is that we don't want MSAA for this one. We don't want MSAA for this one. But we definitely want MSAA for this one. So in the end, the last step we do is a blit from this one, non-MSAA, to this one, MSAA. And this is the issue. It's a pretty straightforward way to solve this, I think. And that's by not using this one as a source texture when we do the blit. Instead, we could do resource data active color texture blit from this one to this one and then in the shader we just access this one. But I don't know. Let's see if they have some more information on why this is not possible. Why mixing MSAA and non-MSAA buffers is not possible. If your piece using MSAA, then the resource data.active depth texture is an MSAA multi-sampled buffer, but in your code you explicitly override the MSAA settings. Exactly like we do. This is exactly what we are trying to disable, pretty much. This is what we don't want to happen. So, if your mask is very peculiar on its MSAA behavior, you will have to generate a multi-sampled mask to a bind MS true texture first. Then in a second pass, do a custom resolve that is appropriate for the sort of mask you need. Exactly, yeah. So that's, if we change the render graph here to do non-MSAA, 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 MSAA. I guess we could do this in a little bit of a hacky way. As I mentioned, by doing a blit from some temporary texture and using and accessing this texture with the outline RT handle instead. So, you know what? Let's commit this first. Let's commit this first. Let's clean it up, commit it, and then we can experiment. Because I really want to be able to use MSAA in this project, but I don't want it to screw up my outlines. So if we could do this split, basically what we want to do is we want to do a blit from active color texture to active color texture, but we want to apply a material as well. So it's a question of doing a blit where source and destination is the same again, which I'm not that sure about. But yeah, let's commit this and see what we get. I wonder... this one we don't want to commit. I need to update my git ignore. I want to do some more cleanup here. I want to do... Can we do that now? Nah, let's just commit this and then experiment. Oops. Don't want to play. Sources. Yeah. Just gonna commit without this one. Remove it rather. Okay. We have a test shader here I want to remove as well. Let's remove these. Migrate render features to render graph. Migrate, create scene texture and outlines renderer feature to Unity 6 render graph. Related to, what is the issue number? 124. Okay, there we go. So what we want to do here basically is this one right here. We need to set outline RT, MS, don't we have this here? Render texture, anti-aliasing. Okay, yeah, so I think this is MSAA. Which will be resolved into a regular texture when switching to another render target. Mm. So if we're talking about one here, one is, yeah, okay, one is disabled probably. So what happens if we do anti-aliasing is equal to 1? We do this here, and we do this here. We jump back. We enable this one. Now we should still be seeing an issue with this, I think. Would be beautiful if we don't, because by doing this switch, we now have no MSAA here for destination. So when we get down to here, this one isn't MSAA'd, this one isn't MSAA'd, but this one is. So I guess we're gonna get the issue at this point. Think. Okay, so we still have this issue. So the question now is if we can... let's try and do this, actually. And if we switch to MSAA now, so now we're not splitting the outlines to the output. So we can see here we don't have any outlines. Let's see if we still get the error now. We actually do. I have no idea. I might have an idea. Do I? If true and anti-aliasing is greater than 1, the render text will not be resolved by default. I wonder if this one is not enough. I'm fucking things up now. We might, let's see, let's remove this one again. Let's disable create scene texture because here we still have MSAA to non-MSAA. But here we shouldn't have it anymore because we commented this one out. So if we try this again, but we disable the scene texture renderer feature, then maybe we won't get this error. So let's disable create scene texture. Let's jump to this one and do 2. We still get it. Which makes me wonder if... I get the feeling that doing this is not enough for the render texture, so that this one is still MSA'd. Could that be the case? Because we don't have anything else in render texture, do we? I wonder if it would be any different if we created it with a render texture descriptor instead and did MSAA samples is equal to none. I don't think so. Okay, this is unfortunate because I think, or I thought, this one we know explicitly has MSAA samples to none. Mm. Mm. Wondering if this is a problem. So I'm wondering if this one. Okay. Or, what the fuck? Maybe, if we do instead, if we don't disable it, but we rely on bind ms. If true and MSAA sample is greater than 1, the render text will not be resolved by default. Will not be resolved by default. So if we set bind ms to true, if we do that instead of doing MSA samples like this, we do bind texture ms is equal to, what was it? If true, will not be resolved. So if we do this instead, we still handle this one as a multi-sampled texture, but we don't resolve it by default. Maybe. Then we get another issue. Okay, but this doesn't work. Fortunate. Do we have, if we take a look at lit material parameters, Hmm. Do we have any other? I want to look at this one. Here we go. Yo, what's up, Perolas? What language is this? We're talking about this. It's C sharp. Okay, this is from 2024. Let's see. Unity 6. Okay, beautiful. Let's take a look at this one. Do you know Rust? I know of Rust. Just haven't done anything in it ever. And I do know of TypeScript. Yo, what's up, Arth? Long time no see indeed. How are you doing? Okay. Yes. Render texture with MSAA has a separate resolve resource under the hood. Unless you set bind MS to be true, yes. It's the future, and the future is now. Hmm. Okay, so we don't have any threads that can possibly help us with this. I still don't know why this one... I still don't understand why we're getting an issue here. Let's comment this one out as well. Like, just by doing this, none of these should be MSAA. MSAA samples, none. Or is this not enough? Like, if we take a look at this, I don't know where this mismatch is coming from. Could it be... could it be this one? Oh... I wonder. Okay, it's not that one either. Actually, what issue did we get this time around? It's the same. I don't know where we're getting the mismatch in this case. It doesn't give me any line. It's probably... wonder if it could have to do with the depth. Mm, this one we don't use, right? No, we don't. Okay, if it's not, it's probably this one. It has to be, right? Fuck yeah, there we go. But if we don't do this one, I think... Ooh. We get an error with this. Yeah, if we don't take the depth into account, we get something like this. How can we get around this? So yeah, it's taking the depth which is MSA aid. And when we try to utilize that together with a texture that is not MSAA bound, that's when we get the mismatch. So how could one possibly get around this or fix this issue? Hmm. If we don't utilize the depth texture here, we are not gonna get the correct rendering. If we do utilize it and we have MSAA enabled, we're pretty much gonna render we're gonna try to render to a target that doesn't bind MS, or whatever it's called, using a depth texture or depth buffer that does. Builder. Do we have raster render graph builder? Raster graph builder. Do we have something interested in here? Set render func, use texture fragment, use texture fragment depth. I wonder. I wonder if we have hit a dead end. Where do we have... search for that one, jump to this one. Mismatch. I'm wondering here. Which is not possible. So you need to take camera target descriptor and not override the MSAA settings if you want to use it with the URP depth buffer. So yeah, that's pretty clear. Yo, what's up, Mercenary Mage? Thank you for the raid, appreciate it. Hope 25 is treating you well so far. Thank you, appreciate it. Have a good one. So, if we want to use the active depth texture, we can't change the MSAA settings on the data texture. That's pretty clear, I think. Yeah. Official staff statement. Okay, so we can't do anything about that, which means that if we enable MSAA in this project, we're gonna have our data texture here is gonna have to, we can't override this one. Okay, so if we take a step back, or a few steps back, and we leave this, we re-enable this, and we remove this one. We uncomment this one, and we remove this one. Okay, let's see if everything works from the start of the pipeline to the end of the pipeline. I'm still thinking that, or I'm hoping, okay, yeah, forgot to do one very important thing. I'm still thinking that MSAA disabled. I'm still thinking that we might in some way, like we still keep these textures as MSAA enabled, but resolve AA, we try to remove this automatic resolving of AA. But then again, I don't know if that is even possible. Because if we take a look at, I don't know where we found that information though, but let's take a look at this, what this says here. I wonder if we can set this one, if we can play around with bind MS. But we don't want to do custom MSAA handling. Very peculiar on its MSAA behavior, you will have to generate a multisampled mask to a bind MS true texture first. Then in a second pass, do a custom resolve that is appropriate for the sort of mask you need. Ugh. This means that like if we just do outline data texture description dot bind texture ms is equal to true, bind, yeah. If true, an MSAA sample is greater than 1, the render texture will not be resolved by default. So if we set this one to true for only this one, we will get, probably won't work, but let's take a look at the error we get. A multisample texture being bound in a non-multisampled sampler. Disabling in order to avoid undefined behavior. Please use texture to the MS in the shader. So when we use this one later on, when we use it in here in generate blit, I think, sample texture to the XLOD blit texture, outline data here is the one it complains about. Texture 2D MS Unity. Okay, let's see. This will hopefully not happen to us. Hopefully. This is also something I'm very interested in, but which makes me wonder if active depth texture, but we also have camera depth. Resource data, universal resource data. Let's take a look at this one. Active depth texture. Okay, what is the difference between this one and camera? And active depth texture. Active depth texture, what is the difference between this one and camera depth texture? So could we do... And we then do... remove this one. And instead we do builder dot set render attachment depth resource data dot camera depth. Do we get the same? Do we get the correct result here? No, we get the same issue. Okay, so that's probably not camera depth texture. Like what I'm trying to get at is, do we have a depth texture that is not MSAA? This is even worse. Okay, so let's ignore that solution again. So we remove this one, and let's see if we can just handle the multi-sampling ourselves on the in the shader. So what error? Okay, we're back to this point. So the question is then, if we do bind texture ms true and then we handle the ms ourselves in this shader. Never done this before, so would love to know. Get dimensions, returns the sample position for the sample index provided. Like, is it possible to just read? I'm imagining that we have access to the default data, like the unresolved data. So I just want to get the pixel value. Feels like hitting a wall here right now on this issue. I was so optimistic about being able to solve this now in Unity 6 because I really want to bring back MSAA to my project. But if we work, we're having renderer features that renders to the output screen. Like this data, we don't want this to get anti-aliased. But yeah, I guess, like, if I were more knowledgeable with sampling multi-sampled textures, or what do sampling these kind of textures on the shader side of things, we could probably get to a solution. Very annoying. I would say that this one is the only but probably just gonna have to postpone this issue. Future me. We can remove this one, I think. Very unfortunate. Pretty much what we get is that the anti-aliasing smudges the outline data, because we resolve this one, making it anti-aliased even though we don't want it to be anti-aliased. It's because the depth text will instead be generated from MSAA depth after the opaque pass. I wonder. I wonder if we do before rendering Skybox. No matter what I do, it seems like this copy depth happens before my outline data render pass. Is that because I do configure depth? Probably. Um, Okay, I'm not. I don't want to give up on this resolve AA issue just yet. I'm gonna try one last thing. I wonder if we can, when we generate our outline data texture, if we can do that pass before we do before our depth texture gets resolved or whatever. What's up, John Olson? Live again? Yeah, hell yeah. Still struggling. Isn't... That's pretty much what programming is for me. Always a struggle. It shouldn't be easy. It shouldn't be easy. Okay, so my last... Okay, I'm gonna try one last thing before I postpone this issue for future me. It's gonna be fun. I'm gonna see if we can do the create outline data texture pass, if we can do that one early. So pretty much... let's disable this shit. Jump to this one, disable this one, and then we do... So we do... here when it said outline data render pass, let's change this one to render pass event dot after rendering opaques. That's all we need. We need the opaques. We don't need the skybox for this. And then I wonder if I want to disable this one as well. Let's see what we get from this. Then also I'm battling with compute shaders at the moment. Oh, nice, interesting. I would love to do something with compute shaders myself. Haven't gotten around to it in relation to Unity just yet. So what are you doing with compute shaders, if you don't mind me asking? Look at this, look at this, look at this. Draw opaque objects, then we have a copy depth, then we have an outline data render pass, still after copy depth. Oh, interesting. We don't get an error. Ooh. Okay. Okay. we still get the resolve here. You can see that the edges are nice and clean compared to these. And if we do yeah, then we get this one again. And also I'm making a medical simulator for IVF for work at the moment. What is IVF? Oh, okay, I get it. So using compute shaders to make an ultrasound. Oh, nice. Oh yeah, I was about to ask if it's in 3D. So I make a voxel data set for part of the body that will be displayed, which you can send rays through the data. Ah, nice. Yep. Love it, love it. I remember doing something with medical images ways back. It was... So these medical images were always given as 3D textures, and then we had to write a shader that could properly visualize that 3D texture. And so then we pretty much did something that sounds similar. So the 3D texture is pretty much voxel data, and then we do ray casting or ray marching through it to properly render it in 3D. Maybe something similar. Sounds very interesting. Okay, so it seems like no matter where we put this in the pipeline, we're always going to have a copy depth, which does copy depth, which does a depth MSAA2 here, which screws our outline data render pass up. What we could do, I think this would probably work. I'm pretty sure this would work actually. Fuck, do I want to do this? This might be a little bit unoptimized, but I want to try it. So basically what we could do... Fuck, do I want to do this? Yeah, let's try it. So what we could do is that we do the depth testing ourselves. But that means that we add an additional texture read for every pixel that should... for every pixel, pretty much. So quickly, let me show cell shade, lit shader. So here, when we outline in the outlines data generation, we read from the depth texture, and if the pixel depth is less than whatever the depth texture returns, we don't render anything. That's one solution, but that means that every shader that implements outlines data generation, we need to do it for every such shader. Yeah. And John Olson, there are plugins that does volumetric things like that, but I need to make something on my own since I need to manipulate the data, etc. at runtime. Okay. That sounds very interesting, very interesting. Do I want to take this step? Maybe I do. Here's the thing. If we do it like this, I don't think we get culling. Actually, I don't think we can do it like that. No, we can't. Or we can. Yeah, I love shaders, but yeah, they can be a bit tricky most of the time, honestly. Okay, I think... Okay, so doing depth testing ourselves here could probably work, but I don't think I want to take that step, actually. So let's leave this one as unresolved for now and get back to it. Okay, so let's leave this issue as unresolved for now and continue onwards with what we have. John Olson, why did you want to upgrade to Unit 6, by the way, just to learn, maybe? I would say there are a few reasons. I want to get access to all the new stuff because in Unity 21.2 and custom render features, a lot of the things were experimental and not set in stone. It was very experimental. The universal render pipeline as a whole was in a very experimental state. And I want access to the newest stuff. But that's not the main reason. The main reason is I want to continue doing devlogs this year. And when I do these devlogs, I want to go in depth of what I've implemented and how I've implemented it. And if I were to do that with Unity 21.2, a lot of the information I would be conveying would be out of date. So it's basically, I want my devlogs to be up to date. That's like the biggest reason for switching to Unity or migrating my project to Unity 6. John Olson, might take my personal project to Unity 6 too soon, but I don't have any fancy rendering that could cause issues, I think. Yeah, like we haven't gone into depth onto the other stuff yet. We're probably going to do it real soon because we're pretty much done with the render features. But it's my understanding right now that everything else got migrated pretty automatically. I haven't seen any big issues at all. So yeah, the migration process seems to be real nice. But okay, it feels a little bit like a defeat here, leaving this issue as unresolved. But maybe we can take a look at it later down the line when we have some more information to play around with. Okay, so let's exit this issue and move back to this one. Actually, let me just add a comment to this one. I need some of this information we have gathered, I would like to properly link to this one here, so I don't need to. Here we go, this one. Yep, let's leave it at that. Okay, so render features, we have them in place. They work as they previously did. That's beautiful. How we're handling this is a little bit different. So we're gonna have to do some cleanup related to it. For instance, we don't use outline supply and outline shader anymore. We use outlines apply blit and outlines generate blit. This one is still something we use quite often though, so I think we're gonna skip this one. Yeah, this one we're gonna research. Let's just add a task we've completed as well. Or I would say this is the case because we haven't really gone into, like, there's still some few things we can do here, but they're working, so that's good. I want to clean stuff up, but before I do that, I want to take a look at this one. Where do we have it? Can I copy like this? This one. I want to double check this one. Yo, what's up, Harneeth? Are you using GitHub Copilot? No, I'm not. Maybe I should. Okay, let's take a look at this one and see if any information presented here might prompt us to do some changes to our renderer features to make them a bit more optimized. And also, I don't like it, to be honest. Yeah, my experience with, I pretty much have no experience with using AI assistants or whatever you want to call them. ChatGPT seems to be better. Yeah, I've actually, okay, when I say no experience, I have, like, I've done some very boilerplatey stuff with the help of ChatGPT, and in that case, it has been very impressive. Okay, let's see. Today, another tips and tricks. Can I mean, we're still pretty early when it comes to these systems, so the resolve AA problem might get a solution down the line, but I don't know. Render graph viewer. Yeah, we might want to take a look at this one actually. Render graph viewer. Where do we have this one? We know. Can I put it here? Okay. Yeah, I want to get more information here, but I just remember I need to do one thing. I want to change this one back to be render pass event. Okay, let's see what more we have here. We see here that the render feature adds two passes that copy the color and depth, but we can also see that URP copy color and copy depth passes are in the frame. It seems to do... what are we talking about? Copy depth. Yo, what's up, Meister K? Yo, what's up, Diligence? We see here that the render feature adds two passes that copy the color and the depth. Two passes. Okay, are they talking about two passes that copy the color and depth? We're talking about this one and this one. These are the two, not that we have copy depth twice. And then we... Meister K, how is the migration going? Pretty good, actually. Our render features are now working again. And I'm just looking into... I'm just trying to get information on if we can optimize them even more before we move on to migrating some of the other stuff, which I think what is probably automatic. So like, I think most of this stuff has already been migrated and working. Just haven't double checked it yet. Copy depth, outline data, render pass. Why do we have... Okay, so one... Yeah, we do two blitz here. That's why we have two of these. I guess there's no way around that. And then we do scene color. Copy. Diligence, what benefits are you looking to gain from Unit 6? All the newest stuff with the render pipeline, so render graph stuff. But mostly it's because I want to do some devlogs and I want the information I present in those to be up to date. Yeah, it seems like the blur solution we have, which is now working as well, is way more performant in Unity 6 than it was previously. That's pretty cool. Fuck, I'm trying to understand this graph. Outline data render pass. Default shadow texture. Does this mean that we... Okay, it's alive but not used in this pass. Okay. Read access. Okay, beautiful. So let's see. Camera depth texture. Copy depth. Yeah, it's red. And it's red here as well. Copy depth. write access to this resource. So I guess what copy depth does is that it copies the depth from camera depth attachment to camera depth texture. Okay, we read this one, and what do we do here? Unnamed from render texture. Yeah, this is unnamed. We want to name this one. That is true. Let's name this one. That's one improvement we can do. Write access. So this is probably our outline data texture. And that's all we have. That looks pretty damn good. And we can see here also that we read from it, or we write to it here. And then in outline to texture pass, we read from it. And then we have unnamed. We want to fix. Yeah, we want to fix this as well. We want to name these as well. It's just nice. But if we take a look at outlines to texture pass, we read from this one and we write to this one. So this is the outlines texture. And then in outlines to texture pass 2, which we might want to rename, we read from it. And we also write to this one. That's good. Fuck, this looks perfect. It looks like we don't keep resources alive too often. Read and write to them properly. This... Ooh. This one, however... This one is probably the only one I'm worried about. We write to this one. We read from this one, and we write to this one. Blit pass utility. I think this is our scene texture pass. So let's look into this soon. Okay, interesting. Let's see if we can name these. So unnamed from render texture. Unnamed from render texture descriptor. So here. Name. I wonder if we do this. So outline data texture. Diligence. Yeah, this one, render graph viewer. It's part of the engine now. Very nice. Now we have here outline data texture. We write to it here. And we read it here. Okay, that's beautiful. And now I want to name this one as well. My question is, do we want to name it here? We have outline rt dot. Do we have name? Yeah, we do, but I guess we can do this then. Name is equal to, and I wonder if I want to use these names actually. we can start by doing only this one. Let's see if this name fixes stuff. Outlines. I mean, this is our internal shader name. I don't know if maybe that's not so pretty. Outlines. Internal texture name. Private static. Oh, we might want to look into this as well. Maybe we can do this a little bit nicer. I just want to do, let's see here. Let's do profiling as name for now. And we do diligence. Did they merge URP and HDRP, or is that something for the future? Honestly, I don't know. I haven't looked into it, but like from reading bits and pieces, I would say it seems to be the case, but like I can't give you a clear answer. Outline data texture, outlines texture. Okay, that's good. And then lastly, I'm worried about this one. No, I'm not. We read from camera target attachment and we apply to scene color texture. Oh. Diligence looks like you're doing making your own render pipeline. Not really. We're injecting some custom passes into the render pipeline, I would say. Mainly outline data render pass, outlines to texture pass, two blitz here. We might want to rename this as well. And then we also have a Blit pass utility. I want to name these as well. So this one, this one, this one, this one. We're injecting these. So render all objects that should be outlined is this one. This one renders to a texture. This one renders to camera target attachment. And this one takes our scene color and render to oh, that's the wrong name. We're gonna fix that. I wonder if we want to do this one first, actually. Ooh, this is very interesting. I'm gonna... Yeah, okay, I get it. Okay. Can I force an update here? Maybe not. Okay, so now we should be pretty much up to date, I think. Blit pass utility, outline data, render pass, outlines to texture pass, outlines to texture pass. And then we have the blit pass utility first. Outlines, outline data render pass. Profiling pass name. Do we do... Add blit pass name. Okay, we use the same name here. Private static read only string name outlines to camera target as outlines to texture blit name. And finally, I also want a name here. Add blit pass name. Is that so? Pass name. Okay, just to clean things up a bit, make it a little bit easier to read here. Create scene texture pass, outline data render pass, outline to texture pass, outlines to camera target pass ... Pretty nice. Okay. wonder. I don't know if I'm fully understanding this. We can see here that the render feature adds 2 passes that copy the color and depth. So it's this one and this one. Those are the passes, right? But we also see that the URP copy color and copy depth passes are in the frame. That seems to do the same thing. Are we talking about these? Back buffer color? Or... yeah, diligence, I agree 100%. It's a very nice graph. However, we see that the camera opaque texture is only available after running graph. That's the gradient blit. Okay, they're talking about camera opaque texture. This one, it's available here. Ah. Okay, am I not following this? Okay, the gradient here. So where we see that camera opaque texture is only available after the render feature does the gradient blit. So I guess we're talking about this one. And then we have a copy color. We change it, they change it to copy color before it. Oh, I get it. Okay. We see here that the render feature adds 2 passes that copy the color and the depth. Here we have the first depth copy. Here we have the second depth copy. First color copy. Second color copy. So then they just switch it around, so copy depth and copy color is done before, and then we do this one. Okay, I don't think we have... Our is pretty... We don't do any duplicated copies, I don't think. I also wonder about this. Maybe you would want to avoid tying up resources for too long. Does that make sense? But when it comes to our custom render features, we're pretty short with them as it is. So create it and write to it here. Write to this here and use it here. Write to this one here and use it here. That looks pretty good, I would say. Okay. Okay, when you need to blit to the camera color, since you can't read and write to the same render texture, okay, so this is still true, but that makes sense. But very good to know. You need to first do a copy, and then blit back to the camera color. With a new context container, you can just swap the camera color to the new resource and void the copy blit. Okay, so if we ever want to do find ourselves in a position where we want to do blit, where source and destination is the same, we want to use a solution similar to blit and swap color render features to this one. Yes. Read directly from the... So I wonder... Configure input. We probably... Yeah, we don't need it here. But maybe we don't need it here either. Because... we do... this. Because they remove configure input color and read directly from this one. We can't read directly from the back buffer, so we need to set requires intermediate texture to true. So copy color here. We don't do that anymore. Could we then possibly remove this one? But we read from it here. And if we properly remove that one copy depth, if we're able to, could we possibly revisit this one again? Maybe. Diligence, do you have to write less shader code and more C# code now, or no? It's roughly the same. To be honest with you, this one looked pretty much the same amount of code, both shader and C# here. So let's take a look at this one, because that would be very nice. They do copy color here. So here. Oof, that would... I wonder why they don't do the same thing with copy depth. Maybe it's not possible. But I don't think we can do this. I don't think we can do this in our case, because what we do with, let me just remove this one. Because what we do with the configured depth here is that we make the underscore camera depth texture available. If we were to blit directly from the depth texture, then maybe we could skip this one. So I'm pretty sure we can't get away from our copy depth here. Much like they do here, they copy depth here and then write to it, read from it here. I guess if it was the case that they could remove that one as well, they would have. But let's see. We can't use frame buffer fetch on depth format currently, so we can't fetch the currently. I don't want to be too optimistic, but maybe in the future. Okay, some comments on how to organize the code. Using global textures and parameters. We commonly see, yeah, we have, in our solution, we have 2 global textures. Let's see if we can bring them up. We have outlines texture is global. Although, yeah, we don't use it later down in the pipeline, but we're going to use it when we draw transparent objects here. Actually, is it just because this one is okay, like draw transparent objects, we make outlines texture global and scene color texture global, thanks to render texture. We could avoid making them global if we rewrote draw transparent objects a tiny bit, or if we make our own render feature that draws transparent objects and remove this one. But I don't know if we want to do that. If we did that, we could skip making this one global, no, this one global and this one global, and instead just make them alive until this column. But let's see what they say. Yeah, our case is the first one, so maybe it's okay as we do. To avoid the cost of global properties that are bound to every shade in the project otherwise. I do want to avoid this though. And all of this is related to, I'm jumping between issues a lot here, but related to this one. So this is the exact optimization we want to do here. So research if it's possible to replace global textures. It all hinges on if we can replace this draw transparent objects. I don't know. I haven't seen anything regarding removing, like, draw transparent objects. This is not a render pass we have added. This is like in the default URP. I wonder, project settings, graphics. I wonder if it's some setting. I don't know, maybe we need to look into that, but so yeah, when we create outlines texture and scene color texture, these are two textures that are from this point onwards is only used by draw transparent objects. But this is a big but, so we don't want to do any optimization preemptively, because the outlines we use in this game, we're probably going to have to do a custom depth of field solution regarding the outlines, which means that we will probably add another pass here. But still, then we can just make it a little bit... I don't know. I need to get some more information about this before we do anything else. Okay. Probably gonna bring this into its own issue eventually. I want to check Unity 6 render graph remove. What is it called? Draw transparent objects. Very specific. Or rather, remove passes. We know how to add passes and how to remove custom passes, but not how to remove. But I wonder. inject scriptable renderer and QPass and QPass. But we don't need to remove a pass. We could probably go with, yeah, that's true. We don't need to remove a pass. We just make it such that every transparent object we have, they're already using custom textures because we want to work with outlines and stuff like that. So if we take transparent blur box, we just set we just create a shader pass in them, or that uses light mode custom transparent objects, and then we make a custom render feature that renders those objects. And then we remove having these three as globals, and we remove this one as global. And then in those custom shaders, we set references to these two textures on the material. Material property. But can we set textures with material property? Probably. Okay, I think it's definitely possible, but but that's still true. We're gonna need to set it on multiple materials. So we're not talking just about one. So this might be, we might not be getting away from having them as globals. Or we can do it with this. in the end. However, I wonder if it's worth it. That is the bigger question. This one's done. Okay, I want to create a new issue for this one and move this from here to that issue because I still want to keep this one open. Like, it's definitely possible. The question is if we gain that much by doing it. But I just want to write down the to-dos related to this one and have it in its own issue. So 1 sec. Create a custom renderer feature handling transparent objects. 1 sec though. I'm wondering if we have something similar actually. We had something very similar to this previously, but let's re-add it. Okay, so this would involve create a custom renderer feature that renders objects with light mode equal to transparent. Maybe, I don't know. Rework. I mean, doing all this just to avoid, let's see here. Doing all this to avoid, what is it? Two global textures and two global floats, or actually one global float and one global color. I don't know if it's worth it. Eventually. Maybe. We have a possible optimization we can do here as well. Let's see. And that optimization is regarding the format we chose for definitely this texture. We don't need this big. That's just something we copied from here. But those optimization is regarding this one, because I think we can do with just an R8. We probably want to do R16, G16. Maybe. Or we could... Yeah, what I'm getting at is we don't need this much allocated memory for this one. Okay, let me put it like this. Diligence, you too. Thank you for stopping by. So I just want to summarize today, because I'm gonna have to go soon as well. Our render features are now migrated. We still have some tiny stuff concerning optimization to do regarding them, but like they are in the same state as they were previously. So the last thing I want to do is research this, and then we're going to do some cleanup, and then we're done with the render features. We can jump to this one and complete the full migration. I'm going to post on Discord. I probably won't be able to stream tomorrow or the day after, but the goal then is to stream on Friday and finish up this task and get back to the usual stuff. It has been... I've learned a lot when it comes to these custom render features. But I still think there's ways to go. But the good news also is that now when we have this in proper working condition, I can just take this one and remake it a tiny bit and then push it to the outlines repository on GitHub, making these outlines available there for Unity 6. But yeah, so that's to wrap it up. I think we can finish this one this week, but it will have to be on Friday. Yeah, great session. Thank you so much for watching. I appreciate it. And have a great rest of the day. Peace.